Welcome to Hardware Addicts, a proud member of the Destination Linux Network. Hardware Addicts is the podcast that focuses on the physical components that power our technology world. In this episode, we're going to discuss listeners' question regarding simultaneous multi-threading, or SMT. If you've ever wondered whether hyperthreading or SMT truly doubles your multi-core workload, and whether specific workloads can benefit from hyperthreading, this is the episode for you. We're going to unravel all those threads right here on the show. Then we head to Camera Corner, where Wendy answers a question from the community. So sit back, relax, and plug in, because Hardware Addicts starts now. I'm Ryan, your tech guide through the universe, and with me today are my two co-hosts, Wendy, our resident photographer extraordinaire and hardware enthusiast, along with Michael, the software sage and hardware Padawan. Let's find out what tech adventures everyone has had this week. Michael bailed on us, so Wendy, give me something good.
I didn't bail. I was offering this is ladies first. Ladies first. That's what I was doing.
Well, that is very kind of you, Michael.
You're welcome.
And so on, Friday, I get an email from one of the co-ops, and it says their final class is this week, tomorrow, to be exact. And they said for the last assignment, the student was to create a video about some sort of law rule for physics, right? And then it needed to be sent to the instructor by Sunday night. And this is the first time I'd heard about this assignment at all.
That's not fair.
Well, thankfully it was like Friday and not, Saturday or Sunday morning, right? So we had, or I guess it was Thursday. I guess I found out Thursday. And we filmed it Friday, and my poor daughter, when your mom has all of this camera equipment and she needs help getting something filmed for class, like all the camera equipment comes out. So for her physics assignment, we had two cameras going, one up by where she was, and then one down a ways away. She was shooting a bow and arrow to show, I can't remember what principle she was showing at the time.
The bow and arrow principle, of course.
Right, the bow and arrow principle. Anyway, so shooting it. So I had a camera up at her and then another one down so I could get two different angles at her at the same time. And then the camera I was holding was on my gimbal, all this other stuff going on. And then after we got it all shot and it was uploaded on the computer, because she's the one who did, the editing for her assignment, I apologized to her because her mom was crazy and, well, she might end up with the best physics assignment ever.
I love it. I love that all of the hardware came in handy for other family members as well. So now you have an excuse to buy more hardware because you're like, look, it's for our daughter's schoolwork.
Absolutely. I need this lens. So for the next assignment, I can make sure that the video is that much better.
Right. Especially, let's say your daughter happens to get like a B or an A minus. You could be like, C to Magneto, your husband. And if I had just had this more expensive lens, she could have got an A plus. But because you didn't let me buy that more expensive lens, she got an A minus.
Speaking of Magneto, he actually didn't break something this week. I was trying to get some pictures off one of the kids' tablets, and every time I hit the, transfer files on the screen, it would jump back down to charge only, and I was getting kind of frustrated. And he walks up and pushes it on the tablet, and it just magically worked for him. So we have one time documented in the house where him touching it didn't break it. It actually fixed it.
Wow. Look at that. He's learning to control his powers finally.
Yep.
We're getting there.
I got a copy of Cyberpunk 2077, which, depending on who you are out there listening in the audience, you either hate the game because it's buggy and breaks on you all the time, or you're like me and you love everything about the game, even though it's buggy and breaks sometimes.
So how jealous is Matt?
I don't know. I haven't talked to Matt yet, but I bet he is pretty jealous about this one. I have it on the PlayStation 4 Pro is what I'm playing on. So I'm guessing a lot of people are having problems with this game on the regular PlayStation 4. But I also got a gift from my wife, a SteelSeries Cyberpunk branded Arctis one wireless headset to go along with it, so that while I'm playing the game, because it's a very much an adult game, lots of bad language, that type of stuff, the kids can't hear anything, and I look like a cool cyberpunk while I'm playing. And so
That's what matters.
These particular SteelSeries wireless headsets, I'm not going to do a full review on them because we know it's more about the branding than anything else. They're pretty decent. They're okay. The sound profile's decent. It comes with a detachable mic that you can pull on and off, which I appreciate because I'm not in Cyberpunk to talk to people or hang out. I haven't gotten to any elements where that would even be needed in the game. It's very comfortable. The wireless works fantastic on it. It's definitely, the profile's more built towards the lows and the explosions and stuff like that, which is what you want in a cyberpunk universe. So overall, I don't know what she paid for them, but they're pretty decent, but it's more of a novelty item.
But fun all the same.
That's it. And it's such a good game. I love cyberpunk. I love the whole cyberpunk world and theme and everything about it. But that's been, any free time I've had outside of work has all been dedicated to cyberpunk.
Yeah, you're making me want to get that game. That you talked about it for so often now that I want to do it, and I don't want to spend the money because it's $60. It's a full price game, and I'm super cheap, and I want to, but I also want to. So look what you've done to me.
Do it now.
See, the only reason why I know about this game is because one of my fantastic co-hosts on DLN Extend loves the cyberpunk world. He's like you. He loves the storyline and the look and all of that. So I have heard him talking about this game pre-release. I know he's totally stoked about it. And if you have it and he does it, man, are we going to hear about it on the next episode?
I'm telling you, we'll tell him it's perfect and it's never crashed on me. That's a lie, but just tell him that.
Okay, will do.
This episode of Hardware Addicts is brought to you by DigitalOcean. DigitalOcean recently announced their new app platform service, which is a solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let the App Platform do all the heavy lifting for you. It has support for multiple languages like Node.js, Python, Go, PHP, Ruby, and it also supports static sites and Docker. DigitalOcean runs their app platform on their own infrastructure using DigitalOcean Kubernetes, so your costs are significantly lower than with other products. And with this Kubernetes structure, they also provide a smoother migration path so you can take more control of your infrastructure setup. As a listener of Hardware Addicts podcast and a member of the DLN community, you can get started for free, no wait, better than free, because DigitalOcean is giving you a $100 free credit when you go to do.co/DLN. Again, go to do.co/DLN to get started with that $100 free credit on DigitalOcean's new app platform service. And we want to thank DigitalOcean for sponsoring this episode of Hardware Addicts.
All right, so now to get into our core story. I love the feedback that we get on this show. The people who listen to this show, they're a different breed, Michael. They're super smart hardware addicts. They get us. And
they send you, not me, because I'm not.
I think they love seeing you grow in hardware, though. They love to see the progress, because I get questions all the time. When does Michael go from being Padawan? When does he graduate?
When do I get at least a little bit of a promotion, maybe?
Yeah, so we'll think about that. Me and Wendy have to talk in our secret society that we have of Hardware Addicts and see if we can upgrade you. But Mark wrote us some great questions like we get from many people in the community, but this one in specific caught my attention, and I think it's something worthy of doing a show around. It says, "Hey, Ryan, Wendy, and Michael. Loving the show. I built my first desktop computer this year, and the information I've gotten from HA has been invaluable when I was doing my shopping. This makes me so happy when I get this kind of feedback, knowing that people are taking the adventure to go out there and build their own machine. And now when something goes wrong, you know how it's all built. You know how to take those parts back out. You know how to fix it and repair it. That's just a beautiful thing."
Well, and there's nothing more exciting than building your own system, than gathering all the parts and putting it together. And it's so cool that this show in and of itself has helped you choose parts that then you can be that much more happier with the system that you built.
Absolutely. Well said. And he goes on to say, "I have a topic I want to learn more about and was hoping you all could shed some light on it for me. Hyper-threading. I know some CPUs have it and others don't. I know that effectively doubles the virtual core's thread count, but is it truly doubling your multi-core workload? Currently, I'm looking at updating my laptop for work, and I have a scenario to frame this question. 2 laptops, similar spec attributes. One has an 8-core, 8-thread CPU with no hyperthreading, and one has a 4-core, 8 threads with hyperthreading. My assumption would be that the real cores are better than the virtual cores, and the 8-core would be more performant. But are there specific workloads that would benefit more from the hyperthreading? Please fill my brain on this subject. Love it. I love that callback. Thanks, and keep up the great work, Mark. Really good question here. I guess, Michael, to see if you could graduate, which one do you think would be more performant? The 4-core?
Hey, put me on the spot.
I
Okay.
know. I feel like it's important, though, because how many people are like, I know the answer to this, and then they might get it wrong. Or the 8-core with no hyperthreading.
I would say that probably I have no idea. I'm gonna go the road less traveled and say that the 4-core 8 threads, because of multi-core, might be more difficult than a multi-thread structure, because that would be doing it through a software play versus having to have a full structure building on multiple cores. That's
interesting. I like how you went in and gave us the specifics around it, which shows you're learning here. But I'm not sure you're right. We'll get into that in a second.
Probably
Mark,
not. That's okay.
Mark has asked a really great question, and I think a lot of people get confused about this. Is this something you've ever studied about at all, Wendy? Because I honestly, I knew about it. I knew the concept because of building them, but it wasn't something I don't get a lot of questions about this typically.
It's something I've looked into a lot, but I think in most cases where lately I've been focused on more modern processors, which typically have hyperthreading built into them. It's just one of the things that I've, just purchased. But if you're going, as as Mark is, where you're looking at 2 different with the same specs, I agree. This is such an awesome question to break it down to make sure that you're getting the best laptop for the money.
Yeah, and that's what we're going to do here, right? We're going to give you our thoughts as hardware enthusiasts. Obviously, we're not engineers that build these, and we don't have software that's specific for one application or another. But in general, we can give you the general idea here. And I really thought about some examples and came up with a pretty good one that I think will put it into context here. So you have 2 main competitors in the x86 processor world, AMD and Intel. Both of them have a virtual core technology, but not all their processor lines, as Wendy mentioned, have that technology enabled, but most of the newer ones do. But Intel was known for a while of actually charging more for any processor that had this enabled. As competition has increased, you're starting to see some of that less and less, and most lines have it. AMD calls this SMT, or simultaneous multi-threading, and Intel has their own proprietary version, as Intel likes to do often, called hyper-threading, which is what most people call it. So there are other variations of processors out there, like IBM's Power 5, that also have variations of SMT, which is kind of the generic term out there, or Intel's hyper-threading. And that's what we're going to stay focused on in this topic, because obviously that's what he's asking about, was Intel's hyper-threading. But I want to make sure people know that it's called different things, but the general concept is the same. Some slight differences between them, depending on which CPU you choose and how they implement it. For the most part, the idea is the same across the board. All right, so as far as the example that I picked, the best thing I could come up with, don't laugh, Michael, is a fast food restaurant, McDonald's. When you're looking at,
sure, I get it.
how
Makes
do these
total
technologies
sense.
work?
Mhm.
Yeah, because chicken nuggies, you got to get,
of course, Big
you
Macs.
got to get your
of
chicken
course.
nuggies.
You got to make sure you get the McFlurry in there too.
Oh, the McFlurry, yeah, that's a good one. So in a McDonald's, if you picture, because we're in a podcast, so we don't have pictures and things, but in your mind, I want you to picture a McDonald's restaurant and pretend that's our CPU, is that McDonald's restaurant. And the fast food lane itself represents a core. The customer is the software, right? Because they have the instructions on what they want to eat. And the software thread, that's what they're going to be in our example, is the software thread that's going to the line to give the instructions of what they want to eat. So one way, if you see a really popular McDonald's location, that they increase efficiency and speed and get more instructions coming in at a time, you have the same amount of employees inside, but instead of having those employees wait as one order comes in and then wait for the next car to come up and the next order goes in, you have 2 lanes going where orders are going in. So, you can drop, multiple burgers in the microwave. I mean, or however they cook them at McDonald's, on the grill. You can put multiple chicken nuggets in the microwave. So you're getting more instructions hitting at the same time. The orders can be placed simultaneously from those two streams of customers. And that's SMT. That's how SMT works. You have the same amount of people inside. So your resources, your cache, and all that stuff's the same. But you have multiple instructions coming in so that you have no cores sitting idle. And this is going to improve the overall performance. That's the idea of having these virtual cores.
Okay,
So the
I'm
per
going to
clock
first.
cycle process instructions for multiple software streams and requests get handled simultaneously.
Okay, so I was giving you a hard time about this analogy that you've given. I was going to just mock you endlessly, but this actually kind of made it more simple for me to understand, because it did actually help, because you have the two order lanes that merge into one, which is the regular core versus the hyperthreading. So it does work. But where does the ball pit come into play?
The ball pit. That's only if you have kids, which I guess, I don't know what that represents. A corrupted hard drive?
Probably.
I'm not sure.
So no, that's your gaming hard drive.
There you go. That's your gaming hard drive. If you're rendering a video, playing a game as your video's rendering, which is something I've done quite often, right? I'm rendering a video for my DOS Geek channel, and then I'm like, well, while that's rendering, I'll go play a game. You're taking advantage of your cores and SMT to make sure all your cores, SMT is making sure really all your cores are working at the maximum instruction set per clock cycle so that all of those tasks can be done. And of course, that's assuming that you have enough other resources to be able to handle that. Because remember, these aren't actual physical cores, they're virtual cores. So we said all that to get to the first answer to one of the questions. To answer the question whether physical cores are better than virtual cores, absolutely. Yes. But having all your physical cores working at their optimal levels using SMT is even better usually, right? You want if you had the choice between your 8 cores and your 4-core processor, 4 cores with hyperthreading and 8 cores without hyperthreading, the 8 cores is going to perform better in most scenarios. I say usually most scenarios because virtual cores can cause issues with shared resources like cache if you already have a taxed physical core and now you have a virtual core that's also requesting things through that. So it's just going to basically bog your system down.
So you're saying that I was wrong, but that I could be right depending on the scenario.
There's very little scenarios in which you're right, but I'll give it to you that there is a scenario
there's
out
a
there.
Chance.
Well, when you go in, he asked a follow-up question whether hyperthreading truly was doubling your multi-core workload, and it's not. It's not truly doubling it because it's increasing the efficiency of that core based on the available cache and RAM. Again, this creates some inefficiencies, and in general, the number that they give for hyperthreading is an improvement of 20 to 30% efficiency gain. So if you think about that compared to the efficiency you would have of having a whole separate additional core, hyperthreading is a good thing. It's a great thing. That's why everybody includes it. It's not as good as physical cores. It's like the staff inside the McDonald's. If you kept the staff the same, they're still going to be more efficient. But if you added additional staff to handle that second lane, you would be even more efficient, potentially, if you hired the right people anyways. So modern operating systems take advantage of this technology. So does most all software you're running. There are use cases, here you go, Michael, in which SMT isn't necessarily more performant, but for your average consumer, outside of really poorly written software, this will not be a factor for you to consider.
Yeah, I only use software that considers it completely and is necessary for the hyperthreading. Therefore, I'm correct in that particular small scenario.
So I think we've got most of the questions answered here. The 8-core processor without SMT is going to be more performant than a 4-core with SMT. Again, you have to assume a lot of things in that question, which I'm doing here, such as the process architecture is identical in both processors. Physical cores are clocked at the exact same speed, have the exact same amount of resources available to them. Again, I think the 8-core is going to be faster. For the second part of the question, if there's specific workloads in which the 4-core processor with SMT would be better, outside of that poorly written software, I'm just not familiar with any cases where the 4-core processor with SMT is going to outperform an 8-core processor. On the flip side of that, there are cases where some applications perform better with SMT turned off, but it's not something consumers really should be concerned with unless you pick a piece of software and call the manufacturer. It's written on a box and says specifically to turn SMT off. Sometimes for networking or some networking input output operations and things I've heard work better with SMT turned off. So an amazing question overall that had me really thinking about a great, relevant, and current example such as McDonald's chicken nuggies to help answer. And I hope that helped you out there, Mark.
Yep.
So thank you for
that was such a great thing. And now I'm curious about like how many other things can we make analogies for fast food restaurants related to, some other type of topic. We talked about the SSDs versus the HDDs. What fast food restaurant applies to that?
You're gonna have to wait for a future episode, but I like where you're going. That.
It doesn't even need to be fast food, because in one of our earlier episodes, you jumped into something about the cereal aisle, and this is still something that my daughter brings up to me on a regular basis. I can see this continuing to be a theme. Absolutely.
Food seems to be the theme that I can make everything make sense with. I'll compare it to fast food, cereal aisles, whatever, but hopefully that helps. Thank you for an amazing question. And for everybody else, please send your questions to comments@destinationlinux.org. We'll try our best to answer them. Or if they're fantastic questions we think the rest of the audience can benefit from, we'll try to include them in a future show with a food analogy.
This episode of Hardware Addicts is sponsored by Bitwarden. Bitwarden is the password manager that we use and trust. Bitwarden lets you set up things like a PIN to easily access your password manager, as well as additional authentications such as master passwords and adding phrases to fingerprint security, all to keep your passwords safe. Bitwarden is the easiest and safest way for individuals, teams, and businesses to store, share, and sync their sensitive data. Go to bitwarden.com/DLN to get started for free. Bitwarden is a password manager that I trust because it is 100% open source. You can self-host your Bitwarden, and they do security audits. Not only are those security audits performed by outside companies, you have access to everything that company finds. And my favorite part is the last time this was done, there were no vulnerabilities found. Go to bitwarden.com/DLN to get started for free. Or you want to support this amazing open source project, you can do that for $10 a year for the premium account. What does that get you? 1 gigabyte of encrypted file storage, 2-step authentication with YubiKey, U2F, and Duo, Vault Health Reports, TOPT Authenticator, storage and generation, plus priority customer service. Make the smart move like many of the people from our community have. Go to bitwarden.com/DLN to get started for free. If you're like me, though, you'll really want to support this great open source project by signing up with their premium edition for just $10 per year. Thanks, Bitwarden, for sponsoring this episode of Hardware Addicts.
All right, Wendy, take us into the camera corner. What kind of treats do you have for us this week?
Well, on the DLN community forum, we had a really neat conversation that arose. Trent brings up this topic of way back in 2013, Nokia, there we go, came out with a Windows Phone OS Lumia smartphone. The camera which came with the phone was a whopping 42 megapixels. Because of that, the phone is still in high demand. I do wonder if someone has hacked it to do 4K images. Then Trent goes on to say, then look at any sites that sell cameras, and they're all the same, only 16 and 32 megapixels. They are also commanding a premium price, especially for 32 megapixel cameras. Look at this craziness. So he links to one, which is a Canon camera that's $1,300 for 26.2 megapixels. One would figure cameras would have hundreds of megapixel imaging units in them by now. What's going on with that? And anybody who's especially new to Hardware Addicts, because I've talked about megapixels a lot, might be wondering exactly the same thing.
Megapixels don't matter.
Right. Megapixels are not the only thing that matters, But I can see how this would be really confusing to someone who's just on the outside looking in, right? You haven't done a whole bunch of research into cameras and how sensors work. And if you are new to Hardware Addicts, welcome to Camera Corner, because we're going to talk about megapixels again. And if you've heard this before, you're welcome. Okay. But there was some great conversation back and forth with different people in the community, which is one thing I love the forum. If you have questions, head on over there, drop a question in, because, the community loves to help talk about it. But Swans in Flight, a community member, gave pretty much the exact same comment rundown that I would have. And that, of course, as Ryan just said, he's been learning in Camera Corner as well, megapixels are not the only thing that matters. So what happens if you have the same size sensor, right? You're still getting this full frame sensor, this crop sensor, whatever, and then you're cramming more megapixels into it. Well, each one of those buckets is now having to compete for light data, and usually you'll end up with less data in it, right? Because as we've learned before, that what that data is the light energy that hits it will tell our sensor how much light is there, which will then decide what the lights and darks are in your image. And all of that data in lights and darks, how much energy is there as it hits your sensor, will then turn it into a black and white image. There's a light spot here. That's where the window is. There's a darker spot here. There's less dark here. Oh my goodness, a face forms. So if all of these sensors are competing so much for space on that sensor, then each one may not be getting enough data to give you the high quality image that you're really looking for on these cameras. I know that Nikon, maybe Canon was doing it for a while, or they were playing this megapixel game for consumer cameras, professional cameras for a little bit, and then they dropped back down. So some of them were hitting, higher levels, and then they're like, no, we're going to not focus on the megapixel war, but on making the sensors better with the megapixels that are on them, with what's available there. And I can tell you that even though we don't have hundreds of megapixels on cameras, the sensor technology that has happened between my very first DSLR, which we're in December now, so that was 14 years ago that I got my first DSLR. And I still have that camera, by the way. It was a Canon, which we talked about on the last episode. I can compare that 8 megapixel one to I think my other one is 24. My current camera is 24. So yes, there was a jump there, but the sensor technology in the time that was between the creation of those two is the biggest difference in the quality and not the megapixel jump.
And this is the same thing that happens really with all hardware. When you look in the computer market, when you look at monitors, when you look at TVs, they do that same concept where they take something that the general public gets educated in, and then they just go into these wars with it so that somebody can increase that number, and everyone goes, oh my gosh, that's everything, right? Is the megahertz that my machine runs at, or the gigahertz that my machine runs at, or that it's 16 gigabytes of RAM, or 32 gigabytes of RAM, or has an Intel inside, or a Ryzen. But it's really the quality of all the components together
that make
give
the
you
difference.
The speed. And I've proven this a million times in the hardware world, where I will do benchmarks with my machines that will exceed machines that cost probably $1,000 more because they have a way more expensive video card or way more expensive processor, but I'm stomping them because the components that I surround it with are much better. And
yes.
that those poor components around it create bottlenecks. So it's very interesting in the camera world. It's the same thing.
Yeah, that's why I always purchase everything that has gold certified gaming tags slapped on top of it, because that's what makes it good.
Or RGB.
Yeah, RGB.
You
Lots
know you're
of
getting
RGB.
a good product if you have RGB. Yeah.
Everybody needs rainbow vomit. But I'm really glad that the camera community in a whole, as far as the companies and stuff, slowed down and stopped that war. And when it comes to the Lumia line of smartphones, Windows phones, really, that's the best thing that they had going for them, because they didn't have enough of a market, especially with what they had in their app store, to be a major player. And so one of their big selling points was this major camera push. That's how they got their phones out there. Like I said, thankfully, cameras themselves, real cameras, stopped with that megapixel type fight and really focused on the sensor. And another wonderful thing that Swan in Flight brings up is the lens you put in front of that sensor is so incredibly important. Now, don't get me wrong, the stock lenses that come with your kit are a great starting point. For most people, they're going to be all that you need. But if you're trying to create a really high quality image, the quality of that glass, the way it passes information, how it passes that charge and focuses it on your sensor makes all the difference. So if you have imperfections or blemishes, just teeny tiny micro ones inside that glass as it's passing through those layers, that may diffuse a little bit of light. So then it's just a little bit more blurry because that image wasn't focused as well, maybe in, say, one spot, especially towards the outside. On a lot of cheaper lenses, you'll be sharper in the middle where most of the focus is. And as you move to the outside, things won't be anywhere near as sharp. So don't worry about the megapixels. Buy the best body you can with the money that you have, and then really focus on the lenses that you're putting in front of the sensor.
There you go. That's great advice. And what if I have 1 megapixel but a great sensor? I mean, then do megapixels matter?
Well,
Don't answer that, Wendy.
I think the better question is, when are we going to get to gigapixels?
Yeah, gigapixel, right? Why do we only have megapixel?
I mean, that just seems lame. When megabytes are gone, and no one cares about megabytes. We care about gigabytes now. So, where's the gigapixels? Come on.
Where's the gigapixels?
That will be answered in the next camera. No, it won't.
No, it won't.
Oh, well.
All right. Well, that's it. Thank you for this community edition of Hardware Addicts. And that is our 25th episode of Hardware Addicts. And it's over now. It's a wrap. So thank you for listening to the show that brings you your bi-weekly tech fix. And if you're not all lit up on tech yet, then be sure to check out all of the great content on the Destination Linux Network. Head to destinationlinux.network to check out all the great podcasts and YouTube partners available. There's so much to fill your brains with, including we have Chris Weir, GameSphere, which is a new show that's joined the Destination Linux Network. So if you're into gaming, definitely want to add that to your podcast player. And if you want to hear more Wendy, then you need to go check out DLN Extend, because that's another podcast that Wendy's on. And we hear she's really nice on that podcast. So you'll get to see a whole different side of Wendy there. Yeah,
no way.
It's true. That's the rumor.
Remember, there's no such thing as too much hardware. Learn, build, innovate, and grow.
We hope you enjoyed this show, and we'll see you next time for another hyper-threaded episode of Hardware Addicts, where all the pixels are mega.
Look at you. Look at you.
Yeah.
Oh, how cute.